All right, we have notes for special right triangles. So there are two types of special right triangles, the 45, 45, 90 and the 30, 60, 90. So 45, 45, 90 is usually shown one of two ways. So either with our angles labeled, or because these angles are the same, this is an isosceles triangle, which means that you could also just show it with congruency on the sides. So because that implies that the angles are 45s. So on a 45, 45, 90 triangle, everything is based off of the legs because they are the same length. We'll define them as A. And because of how the Pythagorean theorem works, if we take a squared plus a squared equals c squared, that's 2a squared. So if I want to find c by itself, when I take the square root, I get root 2a squared equals c, or a root 2 equals c. So the hypotenuse is always root 2 times the leg. Now that means to go backwards, I would divide by root 2. Dividing by root 2 is the same thing as multiplying by root 2 over 2, just to make your math a little bit easier. 30, 60, 90 similarly has a 30-degree angle, a 60-degree angle, and a right angle. Now on a 30, 60, 90 triangle, everything is based off of the short leg, strictly speaking. So the hypotenuse is always twice that leg, and the long side is always root 3 times that short leg. Now over here on these tables, kind of try to simplify the operations for you. So everything is written in terms of multiplication instead of going potentially with division. So multiplying by 1/2 is the same as dividing by 2, but that's how you get from the hypotenuse back to the short leg. So how the table is set up is I need, what operation do I perform? So if you look at some examples, all right, so we got some 45, 45, 90s. So in this case, I have the hypotenuse, I need the leg, so the rule was multiply by root 2 over 2. So take the leg I know, multiply by root 2 over 2. So that would give me this. 2's can cancel, which gives me just root 2. So down here, this one's the congruency version. So once again, I have the hypotenuse, I need the leg. So take the side I know, times root 2 over 2. So 5 root 2 over 2, and that doesn't reduce, so that's the best I can do. All right, so 30, 60, 90s. So for this one, I have the short leg. If it helps, label them. So this is short, that's hypotenuse, that's long. The short leg is always across from the 30-degree. The long leg is always across from the 60. The hypotenuse is always across from the right. So I have the short leg. I want the long leg. If I look at my rules, take the side I know, times root 3. So 3 root 3. On number 4 here, I have, so label our sides, hypotenuse, short, long. Have long, 1 short, so the rule is multiply by root 3 over 3. So root 8 times root 3 over 3. So these two numbers can multiply because they're both inside the root, so that's root 24 over 3. Now you cannot reduce out of a root, so this 24 and this 3 can't reduce to 8. However, 24 is large enough that I do need to try to do a factor tree on it. So if 24 is 2 and 12, 12 is 2 and 6, 6 is 2 and 3, so that's a pair of 2's. 2 and the 3 don't have partners, so they multiply back together to give me 6 all over 3. And then you would potentially have to reduce the numbers out front here, but those don't reduce, so that would be my answer. All right, that's number 5. Let's label them again. Hypotenuse, short and long. So I have the short leg, I want the hypotenuse, so the rule is multiply by 2. So 2 is not a number inside a root, so it cannot multiply with the 11. So this just becomes 2 square root 11. And that's the end of the section.